In the previous video, we mentioned the mean of the data is also called the first moment. The variance of the data is also called the second moment. In this video, we'll introduce the moment generating function and show you one example how to use the moment generating function to calculate the mean and the variance of a data set. Assume we have 4 cards, and these cards are numbered as 1, 2, 3, and 4. Now, you draw 2 at random and take the sum. The question is, what is the mean of the sum and what is the variance of the sum? We'll start by writing down all the possible outcomes. So you can have card 1 and 2, the sum will be 3. You can have card 1 and 3, the sum will be 4. Then you have 1 and 4, the sum will be 5. 2 and 3 will be 5. 2 and 4, it will be 6, and 3 and 4. So in total, we have 6 outcomes. Let's look at the probability of getting a 3. So the probability of getting the sum to be 3 is 1 over 6. Then the probability of getting a sum of 4 is 1 over 6. The probability of getting a 5 is 2 over 6. Then the probability of getting 6 is 1 over 6. And the probability of getting 7 is also 1 over 6. Let's write the equation for the moment generating function. So for discrete events, the moment generating function is m equals to sigma I start from 1 to n. The probability of such an event exponential xi multiplied by t. Let's plug in the numbers. So m is equal to, the first probability is 1 over 6, and the first xi is 3. So e to the power of 3t, then plus 1 over 6, the second event, e to the power of 4t, plus 2 over 6, e to the power of 5t, plus 1 over 6, e to the power of 6t, plus 1 over 6, e to the power of 7t. Let's take out the common factor 1 over 6. So we have e to the power of 3t plus e to the power of 4t plus 2 e to the power of 5t plus e to the power of 6t plus e to the power of 7t. From the moment generating function, the mean of the data set is equal to m dash 0. Let's plug 0 into t. We'll have m dash is equal to 1 over 6, 3 plus 4 plus 10 plus 6 plus 7. That gives 5. What this tells us is, by randomly drawing 2 cards, the average of the sum is equal to 5. We can move on to using the moment generating function to calculate the variance. By doing that, we'll take the second derivative. So we write down d square m over dt square. Or we can write that as m dash dash. This equals to 1 over 6, 9 e to 3t plus 16 e to 4t plus 50 e to 5t plus 36 e to 6t plus 49 e to 7t. To calculate the variance of the data set using the moment generating function, we can write down sigma square, which is the variance, in the following form. What are these 2 terms? The first term, x square, then bracket, is equal to m dash dash 0, and the x bracket simply is the mean of the data. Let's plug 0 into this equation, and we will have m dash dash 0 that equals to 80 over 3. So sigma squared, the variance in this specific example, is x squared, then bracket, that's 80 over 3, minus bracket x, then square, that's 5 square, gives us 5 over 3. Combined with the previous video, now we have learned two techniques to calculate the mean and variance of a data set.